about you? Who do you think your ancestors are? How did they spread around the world, and who do you think they might have met across their travels? These are some really basic, fundamental research questions that make me tick, and I really want to know when these things happened. So how do I know when? It's a bit like a crime scene. You have to actually come up with a timeline to put all these events in order. So, a bit like sand through an hourglass, I spend the days of my life looking at hundreds of thousands of individual grains of sand, because my big idea is to use quartz crystals as timekeepers of our ancient past. So the hero, or perhaps the villain, because we as a species is an invasive species, is Homo sapiens, our own species. We actually originated in Africa, that's our motherland, and we originated there about 300,000 years ago. We've been around for a very long time. Sometime much, much later, we actually managed to get out of Africa, and we went to Asia and from there conquered the rest of the world. We are still not entirely sure when we managed to get out of Africa, or whether indeed we got out of Africa multiple times. Sometimes we failed, and eventually we managed to do that. But we do know from our genetics that we did actually encounter other human groups in our movement out of Africa. And we know this because we have some of their traces encoded in our genes. I'm talking in particular here about a group called Neanderthals that you might be familiar with. And that green bit that you see on the slide shows the known distribution of Neanderthals right from Britain in the west, right over to Russia in the east. So they were actually present across quite a vast part of the globe. So you mostly heard of them, and a lot of us actually have a little bit of Denisovan in us. There's also another species called Denisovan that I show there in red, and I'll explain the red distribution in a little while. You probably haven't heard about this group because it's only known by its genome. We don't actually have much fossil evidence of this person or humankind in the record. Now, humans, Neanderthals or Homo sapiens, Neanderthals and Denisovans, we can only find in one place in the world, and that's a unique place called Denisovan Cave, located in the Altai Mountains of southern Siberia. And what makes it even more interesting for us sitting here in Australia today is that not only do we have Homo sapiens and Homo sapiens and Neanderthals there, but also the Denisovans, and where we find evidence of them in our modern human DNA today in its most prevalent form is in Australian Aboriginals and in people from Melanesia. So, to answer this riddle of when and where this mystery actually happened, and how we actually met, how our ancestors actually met Denisovans, we need to know a little bit of a timeline, and that's where my job comes in. So, how do I actually measure time to answer these when questions? It is with a technique called optical dating, because it's based on the use of light and trapped electrons. So each sand grain we can liken to a rechargeable battery, and I look at individual grains of sand, so one at a time. As it gets exposed to sunlight or heat in nature, you can deplete that battery over time. But when it then gets transported either through wind or water and get deposited, say, in a cave site in southern Siberia or in Africa or in Australia or somewhere, we can then start to recharge that battery because it's actually exposed to background levels of natural radioactivity. That's omnipresent, it's everywhere around us. So we can actually mimic this natural process in the laboratory by using a green laser beam to illuminate our grains one at a time, and also an artificial radiation source to actually give them a known amount of dose. So if you can think of each of those individual quartz grains that you can see on the disk there as a little individual rechargeable battery, you can see how that process might manifest itself. So we can then calibrate how much light is emitted by our grains for every unit of given dose. And if we can know this information, we can calculate how long those grains have actually been buried in that cave. And if it's associated with human remains or with stone artifacts, we can actually by association then tell how old that human remains or stone artifacts might be. So let me take you to the south coast of South Africa, my homeland, where some of the most important archaeological discoveries of Homo sapiens have been made in recent years. The caves here have been occupied by people for at least 160,000 years, and we know this because we have dated individual grains of sand deposited in the caves along this coast. I will start here at the bottom of this 30-meter long and 14-meter high deposit at the archaeological site of Pinnacle Point, where I've spent a considerable period of my career looking at individual grains of sand. Here you can see the earliest traces of human occupation at the site in the form of fireplaces, which are those black lines that you can see in the section on the screen. Now, each of the blue dots is a sample of sand grains that I've collected and dated to find out when people actually occupied the site and what they did there. We have uncovered hundreds of thousands of stone artifacts and animal fossils, which dates to between about 90,000 and 50,000 years ago from the site, a critical period in the evolution and development of the modern human mind, the way we think. During this period, sea level was also much lower than it is today. At times, it was up to 30 kilometers away, so they looked down at a swampy coastal platform. So it also gives you information about the environmental conditions that these people lived in at times of climate change. And another interesting feature is that people only visited the cave from time to time, as shown here by the colourful dots, which shows the clusters of stone tools and artifacts uncovered during excavation. Other sites in the same region have also yielded spectacular artifacts such as shell beads, engraved ochres, stone spear points and bone points, as well as ochre containers, which shows or represent some of the earliest known artists' toolkits in the world at 100,000 years ago. These finds have absolutely revolutionized our understanding from when we first started to behave the way we do today. And the hallmark of our behavior is the use of symbols. And we convey the meaning of symbols through the use of language, something that we think is unique to our own species. Homo sapiens also left Africa at about this time, heading into Asia and across to Australia. And one of the most intriguing sites in Asia is the Denisovan cave in southern Siberia, which was occupied at various times in the past by this human trifecta, Homo sapiens, and also the two more archaic human species, Neanderthals and Denisovans. This cave became famous only a few years ago because geneticists discovered the existence of Denisovans and their living connection to Aboriginal Australians and Melanesians. What has been found in the cave? Well, like most archaeological sites, mostly stone and bone tools and animal fossils, with only what we're really looking for, only about half a dozen human fossils, and mostly it's in the form of a few isolated teeth and a few scrappy bones, some of which have even gone through the gut of a hyena. But because of its cold climate location, it is Siberia after all, the DNA is unusually well preserved in the site, both in the fossils and in the sediment. So much so that the entire Denisovan genome was constructed from just that little pinky bone that you can see on the screen up there. Interesting also, they had some really chunky molars, and that is about as much as we know today about their anatomy. But when did the Denisovans live and die? And have they ever interacted or perhaps even interbred with the Neanderthals and our ancestors? These are questions that, make me tick, and I'm busy researching them with my colleagues in Russia, in Germany, and in Australia. But what we do know so far about our dating of individual sand grains is that those three human groups have lived and occupied the site on and off over the last 300,000 years. This is also a time period that we know Homo sapiens, our own species, developed in Africa and populated that continent. So I'm just going to finish here in Australia, where there's a much shorter time period for human occupation, but nonetheless also still represent a considerable period of time. I love living in Australia because there's lots of sand, lots to keep me busy, even though there's not much else. Its location down under also can be thought of as Roots End for those early migrants out of Africa. Recently, I, with colleagues, redated this site called, in the top end of Australia, called Majababy, where stone artifacts and ochres were excavated from sand layers deposited up to 65,000 years ago. This makes the first Australians descendants of some of the first Homo sapiens that exited Africa. Importantly, it is this very early culture that we still recognize today in the vibrant rock paintings and in that really deep-rooted connection of Aboriginal and Torres Strait Islander people to their country. New discoveries and technical advances, of course, make my storytelling really challenging because it springs surprises on us every day of my life. So I will continue to spend the days of my life working on my big idea and look through yet more hundreds of thousands, if not millions, of individual sand grains to continue to shed further light on the mysterious past of our ancient ancestors. Thank you.